Can we start? OK. Hi, everyone. I'm Lajos Gerecs. I work at 7 State, part of Erlang Solutions. I'm a senior engineer. There, I work in the RabbitMQ team, and we help our customers maintain their RabbitMQ infrastructure, design their RabbitMQ solutions, and we also do RabbitMQ support. I think from this conference, you can see that RabbitMQ is out there. So it's a pretty popular software. And I think I can safely say that we have talked to over like multiple hundreds, let's just say, of companies who use RabbitMQ already. And we saw a lot of use cases. So is there anyone here who does not use RabbitMQ? There is one person there. Yeah, that's what I expected. Basically, I think RabbitMQ is basically in every company who has messaging needs. It's deployed. RabbitMQ is used everywhere. My goal here today is really just to provide a high-level overview of the features of RabbitMQ, so you can go to your company and extend your usage of RabbitMQ, and to showcase that it integrates with a lot of industry standard tools. So basically, it can fit into any kind of environment. So start with the messaging part. I guess it's not really a surprise to anyone that RabbitMQ is a message broker. So the simplest use case, which, sorry, Zoom just finished converting. Yeah, is like one queue, right? And this one is already very useful because with a single queue, you can work around your consumers being unavailable, right? So the main feature of RabbitMQ in this case, and I think I would say a very high percentage of RabbitMQ users, is to provide some decoupling between the publisher and the consumer. Right? So the publisher publishes a message into the queue, and then that message is independently consumed by the consumer. And this gives us like RabbitMQ gives us a way to buffer that message, right? And it will hold on to this message for the consumer, basically. And again, it gives us a buffer. And if we take down the consumer for maintenance, the consumer can continue where it left off, basically. So yeah, this is the simplest usage you can have with RabbitMQ, and this is already, I think, a very useful one. We see this a lot, right? So the most common one is when the consumer service is actually slow, right? That if it takes seconds to process the message, your front-end service cannot really wait for that processing to finish. We see this email sending or generating reports and stuff like that. But I think you can see that basically anywhere where the backend service is slow, this is a workable solution. In some scenarios, we want to make this a little bit more complex, right? Is because we want to send a reply to the client, which is, I would say, 90% of the usage of RabbitMQ, because you want two-way communication there. So the client sends a request to the service sends a reply to the client, and that's basically the main pattern you would implement with RabbitMQ. Now you can see here that there are two queues involved in this setup, one for the service and one for the client. Right? And RabbitMQ gives us a way, like gives us multiple ways to implement this kind of architecture inside. What we need to think about is like how long the messages need to live, like in general, right? I think you would be surprised that many like life-critical scenarios, the messages actually don't really live very long inside RabbitMQ, even though the messages themselves are very important. So what do I mean with that is that it's very common for applications to kind of throw away old messages because for any reason, even if the messages are very important. So that's what you need to think about. You need to think about how long the queues need to live, right? So again, these are all connected in some ways, but probably you have heard a lot about quorum queues today or even last year. And those are supposed to live for a very long time, right? Quorum queues will live until you decommission the application. And how long the consumer lives as well is something you need to take into account. So it's very common today to have your consumers in Docker or like Kubernetes, right? And in there, these containers are very sacrificable, let's just say. So they will not come back if they go down in many cases. And in those cases, your consumer, the lifetime of your consumer is just the lifetime of the container. So there is some high chance that the queue doesn't need to live very long, or the messages don't need to live very long. So RabbitMQ essentially gives us 3 ways. Now with RabbitMQ 4.0, the decision tree is simplified a lot there. So you should use quorum queues if the messages or the queue is important, right? So you deploy your application, the queue is there, it will never be deleted, you don't clean up the messages. Messages live essentially forever, right? So that's where you would use quorum queues. RabbitMQ gives us exclusive transient queues as well. This is kind of important for 4.0. I don't know if you have heard about these changes, but exclusive transient queues are allocated to connection, right? So what that means is that if you get disconnected, the queue and the messages are basically deleted. But this is a very nice way to save resources, because actually one of the biggest issues we see with RabbitMQ is that the messages pile up and no one is really consuming them. So it is a very good way to lower the resources on your RabbitMQ instances, is to use exclusive transient queues. Potentially, it can give you even higher throughput than quorum queues and lower latency as well. But I would say the best one, and which not a lot of people really use, is the direct reply mechanism of RabbitMQ, which does not involve any queues in the system. So you can look it up, but you use a special identifier for the message, which does not involve any kind of queuing or anything like that. It goes directly to the consumer, which means it's the lowest resource usage of them all. The drawback is that in this case, there is no queue, so there is no monitoring, there is no buffering. It's an in-memory structure. So if something happens to your consumer, the message is lost, but still it is I would say it's very common to kind of optimize your RabbitMQ usage this way because it lowers the resource usage by a lot. These are the building blocks of your RabbitMQ usage, right? But in many cases, the reason you would deploy RabbitMQ is to scale your services horizontally, right? So you would want to deploy more replicas of the same service instead of, let's say, deploying a very large instance of your service. And this is, I think, probably one of the strong points of like with queuing with RabbitMQ, or like queuing in general. So in this case, what we consider is this top message flow. So the client sends a request to the service, and we want to scale the service, right? So we don't really take into account the reply queues in this case. Did it change? No. Okay. So the easiest way to do this is you just deploy multiple instances of the same service. Right? So this is what you can see on this picture. We deployed 3 replicas of the same service, and we connected them to the same queue. I think one of the misconceptions people have with RabbitMQ is that you cannot attach multiple consumers to the same queue, which, because I drew this, you can see it's not true. You can attach multiple consumers to the same queue. And the other misconception there is that if I attach multiple consumers, then they will receive the same set of messages, right? So if I publish message A into the queue, then it goes into all the replicas, and that is also not really true. But many people think that because they are reading from the same queue, they will get the same messages. So what we call this? We call this competing consumers, right? Because the consumers are competing for these messages, and this can be basically a very easy way to scale a service with RabbitMQ, because you just attach the same service to the same queue, and then they will just pick the messages off of the queue depending on, let's say, it can provide you load balancing as well on some level between the services, but let's just say the messages are more or less distributed equally between the service replicas. And we see this a lot, like I already mentioned, like sending emails, right, is like the most common thing, something you don't want to do in application, like in your front-end application, because it's slow and it can take a very long time and it's kind of unpredictable. And this can be a very good way to kind of speed that up a little bit. But for example, in many cases, actually, it doesn't really help, right? We talk to a lot of customers, and they have, let's say, 100 consumers for the same queue. And if your database is slow, there is nothing really to speed up in those kind of scenarios. So your service will not be faster, sadly. And another thing which you can see from this, which gets broken, right, is that people use queuing for ordered messages, like for an ordered message flow, right? So if I publish one message, I want to consume that message first, and the next one, and the next one. And in this kind of setup, that doesn't happen anymore. The messages are kind of randomly distributed between the consumers, right? So you can end up in a situation that the messages are processed in different order. Thankfully, that's not really a problem for many use cases. Though RabbitMQ gives us a solution to work around that as well. So what we can do is we just introduce more queues into the system. So instead of attaching the consumers to the same queue, we just create more queues. This can potentially give us higher performance as well. I don't know if any of you are pushing RabbitMQ to the limits, but quorum queues do have a limit where they will not get faster, so there is not really a need to introduce more queues in there. But for example, if we talk about exclusive transient queues, those are more or less, okay, with some asterisk there, but can scale with the number of queues. So in this kind of setup, the special part here is the exchange, right? So we have to introduce an exchange which distributes the messages between the queues. If we want to keep the order of the messages, we should use either a special exchange, the consistent hash exchange, which makes sure that based on some kind of identifier, the messages with the same identifier go into the same queue, right? So that's what we want. So it's very common to have this kind of setup when the backend service has a state for the user. So let's imagine that there is a football match going on, right? Then the service will have a state for that match, and you always want to have the messages in order for the same match go to the same service. Otherwise, either you need to keep the state in all of the services, which is probably not what you want, because that's why you decided to have multiple replicas. Or like allocate more memory or something like that. But this is very common in those kind of scenarios where you have to keep the state for the service in memory, let's say allocated to a web user or something like that. You can implement this without the consistent hash exchange as well, with the topic exchange, for example. But then you have to keep the metadata in your clients. So you allocate your client, your user. Let's say user A goes to Q1, user B goes to Q2. So then the distribution is kind of on you, and you cannot just, let's say, remove a queue when you want it. But that's also very common to have a set of users dedicated to a queue. What I would say to not do is to not create as many bindings as many users you have, because until some point, RabbitMQ works fine if you have a high number of bindings, but when we get into hundreds of thousands, then it gets slow. So it's not really. And I'm not even talking about the message flow. I'm talking about more like restarting RabbitMQ and similar operational procedures. If we don't want to keep the ordering, then we can fall back to the previous way, right? It's like basically randomly distributed flow with the same type of architecture, because RabbitMQ has the random exchange, which can randomly distribute the messages between the queues. This can kind of allow you to scale in terms of performance, right? But what we have seen is that actually, probably, depending if you have reached the limit of the queue, probably it will not help. But again, with transient queues, it can help increasing the performance. And in RabbitMQ 4.0, the RabbitMQ team has introduced the local random exchange. What that does is that if you have a cluster, then the messages will not involve clustering, right? So basically, with that kind of setup, you can have the lowest latency and highest performance with queues, at least. And these are the basic building blocks of messaging with RabbitMQ, at least with queues. Though RabbitMQ has streams now. I think we have heard a little bit about streams today, so I will not mention really. I will not go into that deep detail here. I want to mention the main difference between a queue and the stream, as we have heard in the talk before, is the destructive consumption. And so if I take the message out of the queue, it's destroyed. And from the perspective of the queue, it's like deleted. No one else can consume the message. And with streams, that's not really true. Right? So I can have as many stream readers as I want to, and they can read the same message multiple times, as many times as it's needed. So that basically, what comes out of this is that if you have multiple readers for the same stream, they can read in parallel, they can replay the messages. That's the difference in very short. From this, we can kind of compare queues and streams, right? I would say queues are very good when you want to coordinate inside RabbitMQ, right? So we have discussed that you have competing consumers for the queue, and you can think of it like that the queue keeps track of the state of the message, right? Because the queue remembers if it was consumed or not. Right? So that's easy to reason about, I would say. It's like what's in the queue is in the queue. Right? So there are no questions about it, and then RabbitMQ handles the coordination between the consumers. Comparing this to streams is basically the stream has the data stream, and it's not 100% real. RabbitMQ holds its hands up and doesn't really help you. There you have to kind of keep track of where you are in the stream, especially because you can receive. If you, sorry, I'm running forward a little bit, but basically that's the main thing here is that queues give you coordination inside RabbitMQ, and then streams give you you have to coordinate outside, basically, or in some other ways. Streams do have features of coordination as well. Also, streams are very, very high throughput, so they are much more they're much more fast much faster than queues. What we see with our customers is actually they use streams from AMQP, right? So if you read up on streams before, you see that there is a custom protocol for streams, but that's not something you have to use. And I think many people just opt for using streams from AMQP, which is still much faster than using queues for similar purposes. I think what we have seen is that we used to have a lot of customers with a very, very large fleet of RabbitMQ nodes. So imagine like 20 single nodes, like for the purposes of like just streaming data through, because the queues couldn't keep up with the performance. And today, basically, you can replace the 20 nodes with like a single stream in RabbitMQ. So that's actually very nice. And slightly related to this feature is fan-out messaging. When I say fan-out messaging, what I mean is that there is one message coming into RabbitMQ, and you can see in this case it goes into 4 queues, and then it goes into 4 consumers, the same message. And I was saying that if you attach them to the same queue, right, then they get different messages, and this is how you solve that they get the same messages with queues, right? So this is, you can kind of think about it like in a way that there are like 4 copies of the same message being published into RabbitMQ. And this is not a strong point of RabbitMQ queues, and many stability issues are caused by this kind of scenarios. Obviously not when I have 4 queues, but when I have, let's say, 1,000 or even 10,000 queues, and I publish a single message and it goes into all 10,000, right? That's like that's a very heavy, very resource-intensive operation for RabbitMQ. And this is, I think, one of the main use cases which streams resolves in RabbitMQ, so which was not really possible to do with Rabbit before, because now I can publish a single message into the stream. It will be replicated to all the cluster nodes, and then the consumer just read from the local stream, which results in lower latency. There is no message duplication, and the performance is just much better than with queues. So if you use this pattern in your application, I do recommend that you replace it with the stream. Your installation will be much more stable. And this is all through AMQP, so you don't have to use the custom protocol, right? And this is a very common use case to have. We heard about this data capture, which is a common thing to do with RabbitMQ. Maybe people don't call it like that, but it's very common to use RabbitMQ for cache invalidation. So if you have a lot of application instances, this kind of setup was very common because you wanted to invalidate the cache on all of your application servers. And if you have, let's say, 10,000 application servers, that would result in 10,000 queues. And again, this is just a much better way to do it. So this is the messaging you can do with RabbitMQ. Streams are very good for this high throughput data, so sensors, and this one is very nice because people were suffering because of this. So this is about messaging. What? Deployments. RabbitMQ can be deployed in many scenarios. I think that's another strong suit of RabbitMQ is that you can deploy it on Windows, you can deploy it on Unix-based systems, on-premise and cloud installations, in containers or bare metal or VMs. So we see basically everything. I think only thing we don't see is that Raspberry Pis are thankfully not being used as like production deployment vehicles for RabbitMQ, but probably someone does have it actually. But yeah, that may not be a good one. But I think, yeah, RabbitMQ can be deployed pretty small instances as well. So we see regularly, like sometimes we get customers like one core allocated to RabbitMQ for production, but that's maybe a little bit too small. But we see very small instances of RabbitMQ. We see very big ones. So this can raise, let's say, 100 cores, let's say, which is may not be that useful for RabbitMQ, but if you have a lot of connections, for example, it can be a good one. We see single node installations. We see clustered installations. We see clustered installations. Basically, again, big advantage of RabbitMQ is that what you deploy on, like what the developer has on his or her laptop, right? It's basically the same as you would have in a cluster. So the behavior is the same. Obviously, there are some error scenarios you need to handle, but the configuration is the same. How the streams, queues, whatever works inside RabbitMQ is the same. And this is true for a single node and a cluster as well, more or less. What we see our customers do is these hybrid cloud setups. So we see two different ways of doing this. Some people deploy RabbitMQ in the same RabbitMQ like all over the place, right? So imagine that you have an application and your customers are big companies or small companies, but they want to host the application on premises, and then you would just make 100 copies of the same RabbitMQ installation. And then a customer comes to you and they say, like, we want high availability because we have it in the internal development nodes. We need to have high availability, so you can just deploy a cluster for them. And then we see this many times that the same company has a software as a service version of the application, and that is also essentially uses the same kind of architecture as the on-premises architecture. And then we see connected installations. So that's when these on-premise RabbitMQs are connected to a central RabbitMQ, and we see this a lot. So we see this for like hospitals, airports, solar installations, whatever you can imagine. And again, the good thing about that is the RabbitMQ buffers locally. When the connection is back, it sends it to the cloud or some central location. So you can do this out of the box with RabbitMQ, like Shovel or Federation. So this is a very, very common scenario. And then, as I mentioned, RabbitMQ can be deployed in containers. So RabbitMQ has an official Kubernetes operator. If you are already using Kubernetes, then you should use the operator, because there are some other ways to deploy on Kubernetes, and they are not that stable. And the official operator works around the quirks of RabbitMQ, so it will mostly protect you from like taking production down for 99% of the cases, I think. So if you are already using Kubernetes, it's definitely recommended. So these are how people deploy RabbitMQ. It does have some integrations as well with a lot of industry standard tooling. The main one is Prometheus and Grafana. I think there will be a talk about Grafana dashboards later. If you are not using this, please do start using it, because it is very nice. It stores historical metrics, which is not true for the management interface. I know that when you are looking at it, it kind of looks like it's true, but if you restart the node, the statistics are dropped. So yeah, please use it. It's very good for troubleshooting, and it has historical storage, so we can go back and look at it if it was an actual RabbitMQ issue or something like that. We do have dashboards at 7 State. We created these. You can download them on this URL or with the QR code. There are dashboards for queues, connections, channels. So these are different than the kind of the RabbitMQ overview view page. So kind of like a replacement for the management UI. You can kind of think of it like that. We try to put the metrics there. Too fast. We also have an observability guide. You can get a copy at our stand, or you can download the PDF from our website as well. We wrote up like the main points of how to monitor RabbitMQ with Prometheus and Grafana. RabbitMQ is integrated with a lot of, or at least a few, external authentication providers. So the two big ones are the OAuth provider, which is a token-based authentication, and now it allows you to do single sign-on as well. So you can redirect your users from the RabbitMQ management interface to, let's say, your Keycloak instance or Okta or whatever, and they can log in with the corporate passwords, and the permissions are controlled by these third-party services. So you tell the service what the user has access to. And the same goes for LDAP. We very commonly see it, at least for operators, to use LDAP when authenticating to RabbitMQ, and then they can use their own Active Directory passwords. And for both of these instances, or all three actually, the advantage is that you don't have to add the user to RabbitMQ. So you don't have to manage your operators when they leave the company. You don't have to delete them from RabbitMQ, and you don't have to kind of share guest with like everyone in the team. So it's definitely recommended to use that. And then you can implement your own authentication method. We have seen this with IoT stuff, right? When you have like hundreds of thousands of devices, you don't want to manage them inside RabbitMQ's management interface, though we have seen examples of that as well. But then it's probably better to implement like a web endpoint, and you can implement your own authentication with RabbitMQ. And then protocols. We had a talk about AMQP 1.0. And I think these are two very good recent developments for RabbitMQ. We see a lot of users use AMQP 1.0 to connect to other brokers. I promise it's not always RabbitMQ, but for example, AMQP 1.0, it is Azure Service Bus, for example. If you think back to the hybrid setups, that's very commonly a lot of on-premises RabbitMQs connected to Azure Service Bus with AMQP 1.0. Obviously, MQTT with an industrial usage. And we do see Stomp and WebSocket users, though I guess it's rarer nowadays than it was in the past. So I think with AMQP 1.0 and MQTT, with the recent developments, it is probably really, RabbitMQ is really a multi-protocol broker. What it means, and that means that you publish on one of the protocols, you can consume it in the other protocol, which is very nice because you don't have to kind of terminate the connections yourself in some front-end service, and the RabbitMQ kind of does the conversion for you. So I think that was a very quick run-through of the main features we see used out there, and how people use RabbitMQ. It scales, right, pretty well for everyone's needs. Not always, obviously. Probably some of you are aware of that. And it does a lot of integration with a lot of tooling. So it kind of can fit into any organization. So it is, I think, really enterprise message broker. So yeah, I think that's it. Thank you, and let me know if there are any questions.
All right, thank you. Yeah, do we have any questions? Oh, from the back again.
Thank you for a great talk. I have a question. You talked about streams, and it's good for fan-outs.
Yeah.
When do you think? Do you still think we need a fan-out exchange, or do you rather think we should go with the streams?
Good question. I think it really depends on the number of queues you have, because obviously RabbitMQ will not go down if you have like 4 queues and sometimes you send a fan-out message. Though to be honest, I'm not seeing fan-out usage fan-out exchange usage that much. I think I would say it can stay, but if you need like serious performance for these fan-out messages, then you shouldn't use it because it will take. It is very common. It will take down RabbitMQ. So yeah.
Yeah, I see another question here. Hold on.
Sorry, I'm not that deep into RabbitMQ yet. So maybe a dumb question, but do streams, in comparison to queues, or may messages be lost if you use queues to inform your consumers?
Yeah, so one benefit of using quorum queues is that your messages will not be lost if RabbitMQ goes down, and that's why they suffer in performance, at least partially, that's why. But with streams, yes, potentially you can lose the messages because there is no f-syncing. So
if one consumer is down, then it might lose messages.
So you lose the messages if your RabbitMQ cluster crashes, like all 3 nodes at the same time. Then you will lose the unwritten messages. But it's independent of the consumer. It's more that if the messages are not yet on disk, right, and then your cluster crashes, that's when you will lose. And RabbitMQ will tell you that message is stored, right? But it's in memory. So that's why streams are fast, because they do not have sync. But yeah, that's like the drawback.
Yeah, but it's not like that. If a consumer is down, and while a message is sent, and if it reconnects, then the message is resent.
Yes.
With using streams.
Yeah, in both cases, both for queues and quorum queues and streams, messages are kept. So if you don't have a consumer, messages are kept. There are settings to drop messages as well, but by default, they are mostly kept with some asterisk there.
Yeah. Don't if you want your messages to still be there, don't use an exclusive queue. But
Yeah, exactly.
that was that asterisk that was earlier there.
Yes. I don't know if there are any more questions, or we have time for questions.
Yeah, we have time for a few more if there are any more. But otherwise, I encourage you to come ask questions over the lunch break.
Thank you.